Hello everyone, let us see one more experiment that is included in op-amp and linear IC lab, that is performance parameters of a full wave rectifier, right. So here you can see the circuit diagram. This itself is the circuit diagram what you have to do the connection on the springboard and by making use of the 741 IC, right. So basically you are making use of resistors and these two diodes plays a vital role here. The input what you are feeding for this rectifier, so the rectifier itself suggests that you are converting a given value of AC input voltage to DC output voltage. So you will be having positive half cycle and negative half cycle in AC, and once you get the DC output voltage here, so you will be having output voltage in positive half cycle only, right. Now in order to so here you are making use of diodes here. During positive half cycle one diode will conduct, during negative half cycle another diode will conduct, by virtue of which, so basically if you are making use of a diode you can easily convert AC to DC. So you can observe this DC output voltage on the CRO, right. So here as you are making use of op-amp and diode, here you will not get a pure DC voltage, you will get a pulsating DC output voltage. So if you want to get a pure or stable DC output voltage, in that case you have to make use of a DC voltage regulator. So here you can see that this is pin number 2 and pin number 3, inverting and non-inverting terminal of the op-amp. 6 is the output. So these are the supply voltages what you are connecting here, and these are the positions of the diode and resistor what you can connect to convert AC to DC. So in the waveform you can observe here, this is the input voltage waveform. We'll be having output or input in both positive and negative half cycle, and here you can see that output voltage which lies in positive half cycle only. So this is a pulsating DC output voltage what you are getting by making use of this particular circuit diagram, right. So here you can see that during positive half cycle one diode will conduct, you will get the output. During negative half cycle another diode will conduct and you will get the output in positive half cycle. This is the pulsating DC output voltage what you should get. So once you get this DC output voltage, then you have to calculate the ripple factor. So here in the tabular column you can see that the input voltage what we have fed right now is 6 volt peak to peak. Vmax plus Vmax and minus Vmax you will be having. So if you have a 6 volt peak to peak means what? In positive half cycle you will be having 3 volt. The same thing is noted down here. So Vrms is Vmax by root 2. You will get 2.12 volts. VDC is the shift what you are getting. That I will show you on the CRO, that is 2 volt. So ripple factor that is been obtained is 0.365. This is the practical value. Theoretical ideal value is 0.486. If it is nearly equal, theoretical and practical value, that itself is sufficient, right. Now you can see the circuit which is been connected here. So basically you are making use of an op-amp here, 741 IC. So the required connection you can do to the pin number 7 and 4. So pin number 2 and 3 are inverting, non-inverting terminal, 6 is the output. And these are the diodes which is being used here in order to convert a given AC to DC. So whatever the connection that is been shown in the circuit diagram, the same thing is being done here. And this is the function generator which is being used to feed the input voltage. So because you have to feed the AC input here, and on the CRO you can observe the DC output voltage. This is the supply voltage plus 12 volt and minus 12 volt which is been given to the 741 op-amp for its triggering of 741 IC. And in the waveform on the CRO you can observe here, so this is the output which is been obtained. You can see this is a pulsating DC what you got, right. So a given AC input voltage is converted to pulsating DC, and if you want to get a value of VDC, then you just have to shift here. Here you can see in the waveform here. So this is the reference line what I have considered. If I just shift it, so it will shift to 0.4 division. 0.4 into this phi. So because I am making use of a channel 2, that will become 2 volts. So that 2 volt is been already noted in the tabular column. So hence by conducting this particular experiment, so AC input voltage can be easily converted to a pulsating DC output voltage, and you can calculate the theoretical and practical value of ripple factor. If they nearly match together, then that itself is the objective of conducting this particular experiment.